In this video, we'll take a look at some of the problems that were missed in Quiz 5D, and we'll go through and explain how to properly do them. Also, just making any comments on problems that I've noticed that you may want to be mindful of as you go into future quizzes and tests. So in particular, I see here numbers 9 and 10, 12, 14, and 18. All right, so let's go ahead and get started with 9 and 10. Now with both of these problems, they are asking you to solve by factoring and to find the roots. You've done a great job thus far. You have really mastered the X box, which is so cool to see. Now it's just a matter of applying it. Okay, so for example, with number 9, where you had x squared plus 13x plus 20 equals negative 22, you did a great job of moving all the terms onto one side. So in this case, you'd have x squared plus 13x plus 42, and you forgot to put the equals 0. This is important. The reason why the equals 0 is important is because that's what helps us to be able to later explain what x equals. Okay, so from here you went through and you factored, which you did correctly. So you have the x plus 6 and the x plus 7, which is again equal to 0. We don't want to lose that part. Make sure you have that in there. And from here we then solve for x. Okay, so we've done our factoring, but you are not finished until you say that because of this part, x equals negative 6, and from this portion, x equals negative 7. So remember, we talked about this before with the idea that if I have two items that are multiplied to each other and they equal 0, then either the first party is equal to 0 or the second party is equal to 0. Well, if this first part is equal to 0, we just simply say, well, x plus 6 equals 0, and when we do that, we get that x would be negative 6 in that case. Separate scenario, what if it was the second parentheses was equal to 0? So we just set it equal to 0. So x plus 7 equals 0, and that's how we get the x equals negative 7. So the final answer for number 9 is right here, that x equals negative 6 and x equals negative 7. So we're beyond just simply stopping once we factor. You have to actually find these roots. So you want to explain what those values are. Okay, same thing was happening in number 10. I'll write that over here. So we have x squared plus x plus 7 equals 16 plus x. It looks like there may have been a little bit of a math error here where you subtracted x from both sides, which is correct, but you ended up having an x left over when in fact these x's would cancel, and then once you subtract 16 also from both sides, you would have x squared. These guys cancel out, so there's no longer an x term. Positive 7, negative 16, that has the minus 9, and that equals 0. Okay, so that extra x term you had in there was a bit of a math faux pas. So x squared minus 9 equals 0. Well, from here we know we can just do the factoring of perfect squares. So it's a difference of squares. So x minus 3, x plus 3. Again, do not forget the equals 0, because this is what signals to us that we're going to do some sort of setting of parentheses equal to 0. So for this first set of parentheses, x minus 3, well, when x equals 3, then the whole parentheses equals 0. And for the second parentheses, we would have x equals negative 3, because negative 3 plus positive 3 gives me 0. These two are your final answer for number 10. So as I've said before, with these problems where you have an equation, so you have a polynomial or parts of a polynomial equal to additional parts, move all of your terms onto one side so you have it equal to 0, factor, and then say what x would have to equal in order for this statement to be true. Okay, so you're typically getting up to this step right here and then not making the jump into this section. So make sure to write the equal to 0 and solve it out for x. So from here, let's go ahead and take a look at number 12. So with number 12, you had a question mark by this one, so I said, yeah, let's go through and work this one out then. So we have 5 over x minus 4 minus 9 over x plus 8x over x squared minus 4x. Okay, so you have three different terms that are all rational expressions, three different denominators, so we want to find the least common denominator here. Let's take a look at what happens with this x squared minus 4x in terms of piecing it apart. So I'm going to do that off here to the side. So x squared minus 4x. What do those two terms have in common? Well, they both have x's, so I can factor out an x. And when I do, I factor out an x from the x squared, that leaves me with an x. I factor out an x from this negative or minus 4x, and that leaves me with minus 4. So I have this term in the denominator to be the same as x times x minus 4. And look, excellent. That looks just like these other two denominators that I have here. So we can say that this is going to be our least common denominator, okay, of x times x minus 4. In which case, with this first rational expression, I multiply the numerator and denominator by x. For the second term, I'm multiplying the numerator and denominator by x minus 4. There we go. And this third term, I don't have to multiply by anything because it already has an x squared minus 4x in the denominator. So let's write that out. So that means I have 5x over x times x minus 4. And then it's minus 9 times x minus 4. And that's over x times x minus 4. And then plus this 8x of x squared minus 4x. Or if you want with this x squared minus 4x, we can rewrite it so that it is x times x minus 4. So we can see clearly that every denominator looks exactly the same. Now from here, we'll want to combine the terms that are in our numerators. I want to make a point here. Be careful when you see subtraction. Be very careful. In fact, I would advise that you do the following. I would advise that you write this out on one continuous line, and whatever has been subtracted, that you put it in parentheses if it doesn't already have parentheses associated with it. So in this case, we already do have parentheses, so we're fine. So we have 5x minus 9 times x minus 4 plus 8x. Okay, and that's all going to be over, there we go, x times x minus 4. Okay, I'm going to clean up that 4 there. There we go. Beautiful. Okay. When you see it in this form, hopefully you're noticing that that subtraction, that minus 9, if you will, needs to be distributed into the parentheses, which means once I do that, I'm really looking at 5x minus 9x plus 36 plus 8x. Okay? If we didn't distribute that negative, if we left that subtraction there, then we would have to make sure that however we work out this numerator, we remember to take that subtraction through it, okay? So we should have a negative 9x and a positive 36 if we do this correctly. And that's going to be over our x times x minus 4. Okay, so then I look at combining like terms, so I have 5x minus 9x, that's negative 4x, plus 8x gives me a positive 4x, and that's plus 36, and that's over the x times x minus 4. If I wanted to, I could go ahead and distribute that x into the x minus 4 and have x squared minus 4x. Okay, so this would be my final answer for number 12. Okay, as I mentioned before with number 12, with this top portion, if you decided to do the following, so I'll write it here in pink. If you decided, okay, I'm going to write this as 9x minus 36, that's fine. Just remember to take that negative, put this in parentheses, and put that subtraction outside of it. Because once you do, hopefully you'll see when you distribute that negative, you get negative 9x, and a positive 36, because it's a negative times a negative, which gives us a positive. All right, so that's number 12. And let's take a look here at number 14. 14, we have, let's see, this is an x minus 1/7 over 1/7 minus x. So you had a question mark by this one as well, and when you worked it out, you had 49x minus 7 over 7 minus 49x, which is a legitimate answer. We can actually go one step further with this, and hopefully you'll see this as I'm explaining it through. If you look at what you have here in the numerator, that 49x minus 7, look at how it relates to what's in the denominator, 7 minus 49x. It's like you took the two terms and they swapped positions. So if, for example, we were to write this out, it could be something like just x minus y over y minus x, right? They just have the same values, but they swap positions, and there's a subtraction in each of them. Well, let's look at what happens if you were to just use numbers in general, okay? Or really, we won't even do the numbers piece. We'll just simply work with what we have here. Because of the fact that they're swapped, it's like you could pull out a negative from one of them, okay? So effectively, when you have this 49x minus 7, let's say we were to put a negative here. If I wanted to pull out a negative from both of these terms, right, I would have a negative 7 plus a 49x. Or another way to explain it is that the denominator is the opposite of the numerator, or vice versa, okay? So writing this in a way that hopefully makes sense, we have 49x minus 7 over the negative version of 49x minus 7. So the only difference between the numerator and denominator is that this one is a negative version and this is the original, okay? Once we do that, hopefully you can see that we could actually cancel these guys out, which leaves us with 1 over negative 1, or just simply negative 1, okay? So with number 14, you were super close. Going that extra step would have been to seeing that you could just simply have negative 1. And you kind of see it here in the very beginning because you have x minus something and then that same something minus x. They're just swapped or flipped around. Not swapped, but they're in two different positions, okay? They're just rotated. So that equals up to negative 1. All right, and last one, number 18, is as follows. Okay, so number 18, this was a multiple step one as well. So you have 5 over square root of 10 plus 4 over square root of 13. Now looking at how you had this one set up, you went through and you were correct in identifying 130 as being a common denominator. Because I think if I'm looking at this right, you have 5 root 10 over 10 plus 4 root 13 over 13. Where you ended up making the mistake was that you identified the denominator, the common denominator is 130, but you didn't multiply the numerators accordingly, okay? So for example, with this first fraction, you'd multiply the numerator and denominator by 13. And with this second fraction, you would multiply the numerator and denominator by 10. So if you do that, then you would have the following. 13 times 5, which gives us 65. So it's 65 root 10. And then we would add to it again also over 130. But we don't just simply have 4, we have 4 times 10, which gives us 40 root 13. Okay? So I'm looking at 65 square root of 10 plus 40 square root of 13 over 130. Now each of these pieces, each of these terms are all divisible by, goodness, it looks like by 5 if I'm not mistaken. Yep, they're all divisible by 5. So let's try that out. So 65 divided by 5 gives us 13. And then 40 divided by 5 gives us 8. And then 130 divided by 5 gives us 26. Now, if you weren't sure of how to do this part, and this wasn't necessarily very obvious to you, you could have thought of it this way. If I simplify the fractions that I have here, the 65, 10 over 10, and the 40, you would be able to find this without having to do so much extra work. So hopefully this helps.